Hi guys, welcome to our video Karl-Pearson's correlation coefficient part 3. If you have not yet watched part 1 and part 2, the link for the videos of part 1 and part 2 are provided in the description box. So first of all, you should watch the part 1 and part 2 and then come to this video. Now part 3 totally deals with change of scale. Now, why is there a need of change of scale? We are going to see a sum and understand for itself. Now, over here the sum is given with the values of x as 600, 300, 500, 400, 200. These are so big values, and y is 850, 350, 900, 700, 650. Suppose according to video 2, we apply change of origin. So you will assume some mean. So for x, I am assuming the mean, let us say 300. If I do that, what will the values of u? It will be 300, 0, 200, 100 and minus 100. Now these values are so big such that u square will be very difficult to calculate and the further calculations will be very difficult. So what we'll do is we will apply something else with the change of origin. I'll divide this u by 100. Now let us see what will be u. It will be 600 minus 300, which is 300, by 100. It will just be 3. Similarly, the second will be 300 minus 300 upon 100, be 0. Third will be 500 minus 300, which is 200, by 100, which will be 2. Then 400 minus 300, which is 100, by 100 will be 1. And 200 minus 300 will be minus 100, divided by 100 will be minus 1. Now these numbers are very small and very easy to deal with while doing the calculations. Now for v, let us say it is y minus, you have to assume some mean. So I am assuming, let us say 600, and the scale is also 100. I am reducing the numbers 100 times. So first of all, 850 will be 850 minus 600, 250, and 250 by 100 is just 2.5. 350 minus 600 is minus 250. Minus 250 by 100 will be minus 2.5. 900 minus 600 is 300. 300 by 100 is 3. 700 minus 600 is 100. 100 by 100 is 1. 650 by minus 600 is 50. 50 by 100 is 0.5. Now what we need to do is we have to just square them. So u square will be 90411. V square will be 6.25, 6.25, 9, 1 and 0.25. Let us do the product u into v. The first one would be 7.5, 0. 2 into 3 would be 6. 1 into 1 is 1. Minus 1 into 0.5 is minus 0.5. Now, similar to the earlier sums, we have to do the summation of u, v, u square, v square and uv. Summation u would be 5. Summation v would be 2.5 minus 2.5 cancelled. 3 plus 1, 4. 4.5. Summation u square would be 15 and summation v square would be 22.75 and summation uv would be 14. So let us note down all these values. Summation u was 5, summation v was 4.5, summation u square was 15, summation v square was 22.75 and summation uv was 14. The formula for r of xy is nothing but n into summation xy minus summation x summation y upon under root n into summation x square minus summation x the whole square under root n into summation y square minus summation y the whole square. but over here we have variables u and v. So what we will do is we will change the formula to uv. But that way what will happen is we will be calculating the correlation coefficient for variable u and v. So you have to remember one thing: change of scale does not affect R. It means R of xy will be equal to R of uv. In the earlier videos we have seen that change of origin does not affect R, and over here change of scale also does not affect R. So R of uv will be nothing but R of xy, which is so simple. So what we'll do is we'll calculate R of uv. Similar to the formula of R of xy, we can write down the formula for R of uv, which will be n into summation uv minus summation u summation v upon under root n into summation u square minus summation u the whole square under root n into summation v square minus summation v the whole square. We have to just put down the values. N was, let us say, how much was n? N was 1, 2, 3, 4, 5. Total 5 values are there. So we will write down n as 5 into summation uv. Summation uv was 14. Summation u was 5. Summation v is 4.5. N is 5. Summation u square is 15 minus summation u is 5 square upon under root n is 5. Summation v square is 22.75 minus summation v the whole square, which is 4.5 the whole square. Now let us simplify this further, and then it will look like R is equal to 47.5 upon under root 50 upon under root 93.75. Now how to calculate this at the time of exam? That is by using log tables. I am going to prepare a separate video for the use of log table tomorrow, and you have to watch that in order to understand how to simplify this further. So I will be writing down the answer over here directly, which is 0.69. So our coefficient of correlation for this particular sum is 0.69. And if you need to understand how to calculate this using log table, please do watch tomorrow's video, which will be uploaded at 4 p.m. Now what we have done is we have selected a sum in which there were very big values. So we made use of change of origin plus change of scale. Change of origin is subtracting assumed mean, and change of scale is dividing by a number. Over here we selected the number 100, which made our u and v very simple. In this way we have solved such a difficult sum with minimum amount of time. So R of uv was nothing but 0.69. This is uv, but change of scale does not affect the value of R, hence R of xy is also 0.69. Thank you for watching the video, guys.